I'm Tim Coyle from Signal Bytes Technology, and welcome to my third update on my connected pool monitor project. Okay, so let's talk about what I did on the pool monitor this last week. So the first thing I did is I got my LCD display to work with the analog temperature sensor. So I was using this Nokia LCD display. It's a graphical LCD. It's like 84 by 84 pixels. And the whole idea is this to have a small little display screen on the actual pool monitor so that I can show things like the pH and the chlorine level and any alert statuses. So I got this working with Arduino, and I got it working with the analog temperature sensor working pretty good. I'm still not happy about the screen quality. The backlighting I think I need to fine-tune a little bit more. But overall, for testing purposes and a proof of concept, I think it's going to be pretty good. And I did do another post this week on my blog about different screens that you can use, like a TFT touch screen. And I'm also looking at, they call them memory LCD displays. So it's kind of like somewhere in between this type of graphical display and like a full e-ink display. So think of something like a Pebble smartwatch. So that might be another option to go that could give me a little bit better resolution. But for now, I'm happy with the way it's working, and so I'm not going to worry about it too much. So the other thing I spent a lot of time on this week was really gathering the different things that I need to really get into testing the pH probes and the ORP probe in order to look at the chlorine levels. And so I've kind of got the stuff together, and I've done the research. I got some of the code base that I need, so I'm really going to finish prototyping and really working on that heavy this week. So I thought I would take a minute here and show you on the video here a couple of things that I have together. So the first thing I'm going to show is this little pH monitor. So this is the doctor meter. This is like $10, and so it's not designed for long-term exposure, but you can see here that basically you take this, if you can look, there's your probe there, you stick it in, and then the little LCD display is going to tell you what the pH is. So this is $10, right? Versus anywhere from $20 to $100 for the more industrial probes that I got. And so I'm going to use this in order to validate and verify my pH measurement. So if I'm measuring a cup of water, or if I'm measuring the actual pool water, I can correlate it to something else. So this is always a good idea if you can, when you're building a test setup, or especially working with hardware and sensors, is you want a way to validate with a known source. So and the way you can validate with the pH especially is, for example, with this meter, they even give you some buffer powder. So let me see if I can show this here. But basically this is gives you the pH at 6.86. So you just add, let's see, what does it say? So empty the powder in a clean beaker, and you have to add deionized water. So it's important not to take ionized water or other water from your pool or your tap, because that'll have its own pH in it. So you got to use the right type of I'll call it industrial scientific level water, deionized, or sometimes you can use distilled for different things. So the idea is they also gave me a packet for 4.01 pH. I don't know why there are these values, but again, so you can use this to calibrate both this pH meter and also the one that the pH probe that I got. In addition to that, I brought some separate buffer solutions. So this one is from Atlas Scientific, actually one of the guys that I got the pH probe from. And so a little hard to see here, but what this is this is just a solution, a buffer solution. So this is a known pH value of 7.0. And even on here, they'll tell you, what temperature and the resolution of it, like 0.02 in terms of the pH. So you can see this is a big bottle, and you can use this to test. So basically you can use this to calibrate, and then you can also use this as you go along to test to make sure that you're getting what you think you're getting. And let's see, I'll show you one of the probes I got. So this is the ORP probe, and you see that they shipped it in this type of buffer solution. So again, it's not necessarily a pH solution, but these probes are the industrial ones, right, are pretty sensitive, and they really should always never dry out, because that can ruin the how they work and the electrode. And a week or two ago, I put up how these probes work and some information on that's pretty interesting. So basically, it's in the solution. You've got an electrode in here, a lot of chemistry that happens, but you put this in whenever you want to measure it, and it's going to send some sort of voltage or current. And it's just got a wire with this BNC type connector. So if we go over here, and this is the adapter board that I got. So you connect in here, and then you've got probably an op amp here or some type of signal conditioning circuit that's basically going to take this very low voltage, low current signal from your probe and basically turn it into a signal that you can read with a microcontroller like your Arduino. So this board was interesting. This was the one that I got from a company called Fidgets. And so this one can actually work with both a pH probe and an ORP probe. And it's actually got a toggle switch on here, which probably just changes basically the gain or the settings of the op amp or the conditioning circuit. So this is going to work great to do the testing and the proof of concepts. And so I think that's it for the different components and stuff. I won't show you the other pH probe that I got, but basically that's what I'm going to do to set this up and run the test. So and I also have a digital water temperature probe as well. So between the three of those, I'll be able to predict the chlorine level in the water, I'll be able to predict the pH, and I'll know the water temperature, which I can use to compensate those other calculations. And so with this together, I should be able to come up with a good reading on the pool water, and hopefully come up with like I was writing in some of my posts this week, trying to come up with what I'll call a water quality, or I've seen some other pool companies or water test companies call like a balanced water equation. So the whole idea is as I've been talking about some of my posts and stuff, is once I start adding in all these sensor measurements or these data measurements, pH, chlorine level, water temperature, total dissolved solids, maybe turbidity, so all these different things that, how clear or cloudy the water is. So if I have, a couple of these different metrics that I can go up and down with, then kind of what I can do is put an equation together and try and figure out basically an alarm or alert system that says, once it falls below this threshold, you probably need to add more chlorine and keep your pool water the way you want it. So I think that'll work pretty good. Okay, so jumping back in here, the last thing is this Hackaday contest I entered. It's kind of, they do this contest every year with some different focuses, but basically anytime you're working on any type of hardware sensing Internet of Things project, it almost always applies. So the deadline's July 24th, which is a week from today, so that gives me 1 week to finish this proof of concept up. I'm pretty sure I'll be able to do it. Like I said, I've got all the stuff I need. Now I just need to do the coding and try and do some verification and make sure that the measurements are accurate, and then I think I'll be all set. So I've got some couple more notes here and some other things I was looking at. But another thing that I need to do for the Hackaday contest is they want you to put together like a rough business plan. And that's one of the things I try and be talking about throughout this project is the business part of it, and business model. So that would actually be pretty good for me to sit down and write up a couple of pages or some slides on just how the business model of this would work. Now for the contest it's pretty loose. They're putting a lot of requirements on it. But I kind of talked earlier in the very beginning of this project how I might do this, of the different ways to get investment money, whether it be crowdfunding or trying to sell kits, or obviously you could try and put together a pitch deck and do investment, but for something on that level you'd really need to have users. So I think probably from a business model point of view, I'll probably go with a crowdfunding, because I think if you do crowdfunding and even if you do it for a small amount at cost, you could prove out the concept. You can say, listen, I successfully crowdfunded this design, I got users now, even if they're beta users, and undoubtedly in that process you're going to learn a lot. You're going to learn a lot about your product and what you need to fix, and what people like, and we can even think of really other services and things you can add to really turn it into like a product 1.0 rather than just a beta. So for my plans next week, like I said, really I need to focus on getting everything done, so when I submit my entry into this Hackaday contest, I actually have a proof of concept that works. So when it's in the pool water, it can measure the pH and the chlorine level, and throw out some data and let you know what your water quality is. For this proof of concept, I'm not going to have the packaging done. I'm not going to have a case, or anything like that. So it can just be in a plastic enclosure box for now. I think that'll be fine. But I think after this, I'll certainly have to start looking more deeply into some 3D CAD stuff and figure out the best way to look at the plastic enclosure and something that can sit in the pool water. So that'll be interesting. See what I can come up with, maybe a nice aesthetic design. And the other thing that I still haven't done yet is really the connectivity part. So, and I probably need to do that this week as well. So I'm going to look at using a Bluetooth shield for the Arduino. And the whole idea of this is I can hook this whole sensing unit up to a Bluetooth module and then just send the data over, say, to my iPhone. And so I bought this development kit by a company called Red Bear, and so they have a free iPhone app, or I'll call it like a template app. So basically you can easily change it so that you can read in your sensor data without having to go through and do a full iPhone app development. So for the proof of concept, I think that would be great. I could use that. I also have that Wi-Fi shield, so I could go and put it on Wi-Fi and just throw it over to a simple web server, so it serves up a web page with the data. So I could do that as well too. So we'll see what makes the most sense, but probably one of those two I need to roll up as well and get that working. So that's my update for this week. Like I said, I'll be working on really the heavy coding this week and get these probes and the water quality working, and then hopefully we'll be able to quickly add some of the connectivity to get a basic proof of concept going. Okay, well, thanks for watching this video, and I'll see you next week.